Here's our first example. We want to simplify each expression. So for simplifying for a logarithm, that means if you can, write it as a single logarithm. Just one logarithm, no numbers in front, just a log by itself. So using our log laws, so we have 3 log laws so far. We have one log law. I'm going to see exactly from your formula sheet what letters they use. And it really doesn't matter what letters that we use. They use the letter A. So when they're just saying it could be any base, your formula sheet uses the letter A. I think your textbook uses the letter B. If you wanted to use the letter, I don't know, G? No, G. I'm trying to think of what letter in math gets underrepresented and might be disappointed in its life as a letter because it's not involved in math as much. You use G sometimes in functions, right? Functions f of x, g of x. A, B, and C, they get used a fair bit. Then E is a special number, so it kind of feels really cool. I don't know. What would be a letter that doesn't get used? D. I don't think D gets used very much. Oh, distance, maybe a little bit. Anyways, your formula sheet uses A. So log A of x times y is equal to log A of x plus log A of y. The important thing is that the base stays the same. What base do we have in our first one? It's not written. Do you remember when it's not written what base is there? A 10. So anytime the base isn't written, that's your common log. It's a base of 10. Since you're adding 2 logs together, and the ones that you're adding together are or both have the same base of 10, you basically have the right-hand side of this formula. And just like identities, if you have the right-hand side of a formula, you can write it as the left-hand side. So this is going to equal log of base 10, 7 times 8, or log of 56. So as far as mental math goes, you can't do log of 7, you can't do log of 8, and you can't do log of 56. So this really wasn't that helpful at this point. Although if we were estimating this, log of 56 we know is between 1 and 2. And we'd probably get a better estimate from that. Then these are both between 0 and 1, but you wouldn't know how big are they. Does it go past 1 or not? If you wanted to do an estimate. Okay, B. We have 5 log 2. Now, another one on our formula sheet says that if you have, now I should use all the right letters. Did I use the wrong letters? Oh, they like to use capital M's and N's. So I'm going to match everything perfectly. So on your formula sheet, instead of x times y, they use big M times big N. So it's big M, big N. Nice. And for the power one, they have a big M as the base and an N as an exponent. And they say that's the same as multiplying out in front. In other words, that exponent has come from the exponent out in front and is now multiplying. So in question B, we see a number in front. If you have that number in front, that's your N right there, it's in front. If you want to change it from the right-hand side to the left-hand side to write it as a single logarithm simplified, then this becomes 5 log of 2 equals log of 2 to the power of 5. So that 5 goes up as an exponent, which if you wanted to evaluate that 2 to the power of 5 is 32. So again, you would be able to estimate that you know that that answer is between 1 and 2. So with logarithms, we call them simplified anytime we have the left-hand side of our formula sheet. And we call it expanded anytime we have it on the right-hand side of those formulas. Our last formula on our formula sheet says if you're dividing inside of your logarithm, that's the same as subtracting. So in the last one, we have log 80 minus log 16. That would be the same. Again, whatever base that you have, and all of these ones have a common base, the base of 10, but you have to make sure that your bases match. That's why the little a is there, saying that it works with any base, but as long as the base stays the same on both sides of the equation. So we have log of 80 over 16, which if you simplify that, that's going to be log of 5. Questions we can do for practice? Are number 4 and 12.